Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework from yesterday. First, we got our M&Ms, the math notes for mixed numbers and fractions greater than 1, which is, they're starting to rename that instead of improper fractions. Don't, you know, call them whatever you want. Improper fractions are fractions where the numerator is greater than the denominator. And so you take a situation like this, 4 1/3. If I were to create 4 circles here, 1, 2, 3, 4 circles. Maybe I'll put them over here on the side so they can fit nicely. 1, 2, 3, 4. And I break each one of these into 3 equal parts. So 1, 2, 3. Let me actually do something here. I'm going to pause and come back so you're not all bored with me doing this right here. So I'll be right back and it'll be all right. So these are a total of 5 circles, right? And each one of them broken up into 4 equal parts, but we're going to take all the parts that are shaded in. So here's one complete circle shaded in. Here's a second shaded in. So this is 3. This is 4. And we don't have 5 complete circles, we have 4 1/3, so I'm just going to shade in this 1/3, okay? So if we want to convert from a mixed number to an improper fraction, we look at our denominator of our fraction, and that's the number of equal parts each whole is broken into. So we're talking about thirds. So how many total thirds are shaded in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 total thirds, and so the 13 tells you the total number of thirds. We could write it this way. 13, no, I don't like that. I want it to look like this. If you take 13 thirds, that's the same as saying 13 times 1/3, and that's what we've got here. You got 13 1/3 pieces. So going back and forth between mixed numbers and improper fractions is an important skill understand, and the process basically involves division, right? If you take 13 and you divide it by 3, how many total 3s can you fit into 13? You can fit 4 of them, right? 1, 2, 3, 4 groups of 3, and that made up 12 total thirds, leaving you with 1/3 left over. So to go back and forth between the two, change from an improper fraction to a mixed number, you do the division process, and whatever is left over tells you the number of thirds remaining, or whatever you're dividing by. That's how many of those fractional units are remaining. Okay, to go in the other direction, let me go ahead and clear everything off the board. If I want to change from 4 1/3 mathematically without drawing the pictures, then we start the process multiplying. Okay, how many thirds fit into 4? And so 3 times 4 was 12, and so you got your answer of 12, and you add that 1 extra third in, so you get 13 thirds. Okay, this is a process we'll want to practice going back and forth because there are times when we want to express our number as a mixed number, and there are times when we want to express it as a fraction. So we need to be able to go back and forth between those two representations. All right, so taking a look at the homework, let me go ahead and just shield that for now. It says how many, stop it. How many tenths are in a whole? Okay, so 1 whole is equal to the number 1, right? And so that would be the same as 10 tenths. That's your giant 1, so yeah, 10 tenths. And how many hundredths would be there? Well, that would be the same as saying 100 over 100. That's another giant 1. So if you want to convert a whole to a fraction, doesn't matter what the denominator is, but whatever the denominator is, the numerator has to be the exact same number. So 10 tenths, 9 ninths, 100 100ths, 10,000 10,000ths, and so on and so forth. Those are all giant 1s equal to 1 whole. The process of converting from a fraction to a decimal. Remember, fractions are division problems. So you just take 2 divided by 3. Now, you know, I repeat a lot of things. You know, a lot of times it takes repetition for students to fully memorize a process. And so I'll state more than once this year that you can tell the direction for doing this division process by just thinking, for the most part, this fraction is less than 1, correct? 2/5 is not an improper fraction. It's a proper fraction, which means it's a number that is less than 1. Greater than 0, but less than 1 because it's a positive number, right? So you've got two choices. Sometimes people accidentally put the wrong number inside the box. But you should be able to recognize that this order is not correct, because how many 2's fit into 5? 5 divided by 2 is 2.5, right? If we go ahead and complete the process, no, that's a 1 there. Complete the process, bring the 0 down, 2 goes in there 5 times. So you know that can't be the answer, because this is a number that's greater than 1. Our answer has to be less than 1 because that's a proper fraction, so you had to have the 2 on the inside, okay? Here, 3 divided by 8, put the 3 on the inside, so you get a 0 in the 1's place. Here, this is actually a fraction that's greater than 1, so in the 1's place, you should have a number greater than 0. And in this case, 30 divided by 20 is 1.5, or 1.5. Mario ordered a pizza for dinner. When it arrived, he quickly ate 1/8 of the pizza. I guess that leaves him with 5/8, correct? If he ate 1/8. While Marco was getting napkins, his pet poodle ate 1/3 of the pizza. And I don't believe he's saying 1/3 of what was left over, but 1/3 of the total pizza, okay? So draw a model to represent this situation. So we draw the pizza as a round circle. If you kind of picture this broken up into 8 equal parts, let me do this, do that, and this. You could cut it in half to begin, then cut those halves in halves to make quarters, and then take each one of those quarters and cut them in half to make eighths. And it doesn't have to be perfectly drawn, but that's the basic idea there. Okay, maybe I get that a little bit better to right around there, or I don't know if I did that perfectly, but at any rate, this is about 1/8 right there. So that would be how much. Who is this? Mario? We talked about Mario here. I can't remember. Yeah, Mario. So Mario ate this, and so once you've got that represented, then the same thing, but break them into 3 equal parts, and that would be the 3 equal parts here shaded in. And so the question is now, what expression will show how much of the pizza is left over? So you've got to take away this section and this section. So we have to add the 1/8 and the 1/3 together. And when you do that, remember, you've got to have common denominators for your fractions. So we're going to convert this, and we can use that coat of arms process of changing this by multiplying it times 8 times 1 and then 8 times 3. So times 8/8 becomes 8/24. And then the 1/8, you're going to multiply that times 3 onto the 1 and 3 to the 8. So that becomes 3/24. So this combined makes 11/24. And now when you subtract away, you have to change this to a whole with a denominator of 24. So you can take 24 minus 11 is 13. And that is a little bit more than half, but it's very close to 1/2, right? So it says about what percent? Well, it's about 50%, because 13/24 is just a little bit more than 50%. If you wanted to know exactly what it was, you'd take 13 divided by 24, and you'd get the decimal number of 0.5416. So you move that decimal 2 places to the right. It's about 54%, but I just rounded it to 50%. So if you said 54% or 52%, somewhere in that range, you got it right, because you weren't expecting to come up with the exact answer, just a close estimate. All right, Nicole is a machine that will produce a number from 1 to 50 when she pushes a button. If she pushes the button, what is the probability of getting a multiple of 10? All right, well, multiples of 10 would be 10, 20, 30, 40, or 50, and that is 1, 2, 3, 4, 5 out of the 50. So if you take 5 out of 50, that's the same as 1 out of 10. What's the probability of not getting a 100? Well, there are no 100s. So you're not, I mean, the probability of getting a 100 would be impossible. So this is certain, or all of them, all the possible numbers would be not 100. What's the probability of not getting a multiple of 4? Okay, so let's go through our list of the multiples of 4. between 1 and 50. And so how many numbers is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means 38 of them are not multiples of 50. So we could write that as 38 over 50, or we could simplify that down to 19 over 25. And then the probability of getting a one-digit number, well, how many one-digit numbers are there between 1 and 50? There's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So the probability, the number of desired outcomes over the total number of possible outcomes is 9 over 50. Okay. And Lyle and his study team are designing spinners. If one half of the section, I'm going to highlight that, one half of the section on the spinner are green, and there are 14 sections, how many are green? Well, this is just using proportional reasoning. One half is equivalent to something over 14. So if half of the spinner is green and there are 14 sections, that means that 7 out of the 14, because 7/14 is equal to 1/2, must be green. If 3/4 of the sections, I'll highlight this in a different color, 3/4 of the sections on a different spinner have stripes and there are 24 sections, how many have stripes? So this is where, what is 3/4 of 24? That would be 18 out of 24, which would 18 out of 24 is equivalent to 3 out of 4. Okay. All right, and that does it for today's homework. So go ahead and get, I guess you're going to finish today's lesson or yesterday's lesson. It was a 2-part lesson, and then you can get headed over to the homework for part 2 of lesson 2.1.1. All right, take care. Bye.
Hey, feeling good, like I should. When in dark, walk around the neighborhood.